Hello everyone, myself Dr. Feroza Demirajkar, and today we will see a 8051 program to transfer 10 bytes of code memory to internal RAM. That is, we want to transfer 10 bytes of data from the code memory to the internal RAM. So now the purpose of this program is to read 10 values which are stored in the code memory. That is, we are storing the values at starting address from 0 into 2000, and we are transferring them sequentially into the RAM starting at an address that is 20H. So here for the table, that is the code memory, we are taking the address as 2000H, and for RAM, that is internal RAM, we are taking it as 20H. This is the process of the program. That is, first we'll be initializing the loop counter R2 to 10 for 10 iterations, and then we'll be using the data pointer, that is dptr, to point to the current table entry, and then we'll use move c to read the data from the code memory into the accumulator. So to read the data from the table, we'll be using, that is the code memory, we'll be using move c instruction. Next is we have to transfer the data from the accumulator to the RAM using the indirect addressing mode. Then we will increment the pointers, that is dptr and r0, to move to the next locations, and we will repeat the loop until all the 10 values are transferred. And what the result we should get here is, we should be getting RAM locations 20H to 29H, and these RAM locations will contain the values from 01H to 0AH, that is 10H. So the values will be copied from the code memory to the internal RAM. Now this is the program sequence. So here what we'll do is, first we'll initialize the data table, which will set up the initial data structure. Then it will copy its contents to a specified memory location. Okay, that is, we'll be using move data operation, and we'll transfer the data from one location to the another. Then here the pointer will be incremented. Here we'll be adjusting the memory address to the next location, and here we have a looping mechanism where we will check the loop counter whether it has reached the value 0 or no, and finally the data will be copied to the internal memory, that is the internal RAM. Okay, so this is the program sequence. Next is memory organization. So here we are using org 0000H. So what does this directive do? So here it will set the origin for the program code to address 0000H. And one more, we are using org 2000H. So this directive, it will set the origin for the data table to address 2000H. Next step is the initialization. So here we are using these three instructions for initialization. First is move R2 comma hash 0A. This is loading of the register R2 with the value 0A H, that is the 10 in decimal, and this will be used as a loop counter. Okay, here we are loading R2 with 0A H. Then next is move R0 comma hash 20 H. So we are loading R0 with hash 20H, that is loading register R0 with the address 20H. That is, here will be data will be copied. Okay, here the data will be copied from the table in this, from this memory location. And the next instruction is move dptr comma hash table. So this will load the data pointer register dptr with the address of the data table. Okay, so what is the address of the data table? So the data is located at 2000H. Okay, what we are doing here, we are loading R2 with 0AH, and we are loading this with hash 20H, and we are loading the data pointer with the address of the data table located at 2000H. This is the initialization process. Next is loop to copy data. Now we want to copy the data. For that we are using a loop. These are the instructions which are being used in the loop here. Okay, and here we'll be using a up label which will mark the beginning of the loop. Now first instruction which we are using is the move a comma hash 00 h. Here it will clear the accumulator a by loading it with 00 h. Then the next instruction is move c a comma at a plus dptr. This instruction, it will fetch the byte from the address pointed by the dptr and it will place it into the accumulator a. Okay, and this at a plus dptr addressing mode, it allows accessing the data table. Then next is move at r0 comma a. This instruction, it will store the value of the accumulator a into the memory location pointed by r0. Then we will increment the dptr to point to the next byte in the data table, and we'll increment r0 register to point to the next memory location where the next byte will be stored. Okay, so what we are doing here, we are initializing the loop, then we are clearing the accumulator, we are fetching the data, we are storing the data. Okay, we are storing the data. Next, what we are doing, we are incrementing the pointers here. Okay, then the last instruction is to check whether the counter has reached the 0 value or no, otherwise it will jump to the label up. So djnz r2 comma up, here we are decrementing the counter. If this has not reached 0, if r2 is not 0, what we have to do, we have to repeat the loop. Okay, so here which are the register we are using? We are using dptr, r0 and r2. And what operations we are doing? We are fetching the data, storing the data, then we are incrementing the pointers, and we are controlling the loop. Next is infinite loop, that is the last step. So here this instruction, it will cause the program to jump back to the label h. Okay, and effectively creating an infinite loop. So it will create an infinite loop, and here this is often used to halt the program after the data copying is complete. Then we are using a data table here. So this is the instruction, that is this line, it defines a data table which will start at the address 2000 h. Okay, and it contains 10 bytes of data ranging from 01, 02, 03 up to 10h. Here it is actually 0ah, and these values will be copied to the memory starting from an address 20h. So here, what are the data values in the table? These are the data values, that is 01, 02, 03 up to 10h. You can take any values of your own choice. Then here what we are doing, we'll be manipulating the data, and we'll be executing some instructions. And here the memory allocation is done by considering the byte size, and we'll be considering the addressing here. And here what we are doing, first we'll define the data table. What is the address of the data table? It is 2000h. And what are the values? These are the values, that is 01 to 0ah, and we will copy these to internal memory location which is starting from an address 20h. So here this program, what it will do is, it will initialize a data table, okay, with what, with the 10 values, and it will copy these values to a specified memory location in a loop. And this program, it will use the registers and the pointers for copying the values to a specified memory location, and to manage the data transfer efficiently. Okay, so here what it will be doing, it will initialize the data table, then it will load the data pointer, it will copy a value to the memory, then it will increment the data pointer, and it will repeat this for all the values, that is until and unless r2 value is 0, that is the counter value is 0. Then it is done until and unless the complete data transfer is being done or being carried out. So this is the program here. Here the first step, what is the first step? It is nothing but setting the directive or for the address 000 that is the starting address is set org 0000h. Then we have the initialization, that is first is move r2 comma hash 0ah. So what it will do, it will load the value 10. Okay, this is in hexadecimal into the register r2, and this will be used as a loop counter to iterate through the data table. Then we have move r0 comma hash 20h. It will load the starting address 20h into the register r0, and this is where the table's data will be stored. Then we have move dptr comma hash table. So here it will load the address of the table, that is 2000, into the dptr data pointer, and this points to the start of the table. Okay, then we will come to the main loop here. So first instruction is move a comma hash 00h. It will clear the accumulator to ensure that it starts with the 00. And then move c a comma at a plus dptr. It uses this instruction, that is move c instruction, move code memory, and this the effective address for the data is dptr plus the accumulator, and the value from the table pointed to by the dptr, it is moved into the accumulator. Then we have move at r0 comma a. This will move the value from the accumulator to the ram address pointed by r0. And then we have increment dptr. It will increment the dptr to point to the next table entry. And increment r0, it will increment r0 to store the next value in the subsequent ram location. Then we have djnz r2 comma up. Here it will decrement r2. If r2 is not 0, it will jump back to the label up, this label, and this creates a loop that repeats 10 times. Okay, because we have given here loaded the r2 with 0a. And the last instruction is h s jump h. So here this is the infinite loop. Once the program finishes transferring all the 10 tables values, it will enter this loops and it will halt. Now we'll come to the table definition here. So here first org 2000h, this will define the starting address for the lookup table at 2000h. Okay, then we have table colon db, and we have given certain data here. This declares the data table containing 10 values from 0 1 to 10h. Okay, and here this is how we give the uh, input. Okay, here at 2000h we already have this. Okay, at 2000h, and at 30h we don't have any values. After execution we'll be getting this. So here this is a flow chart or flow diagram. What we are doing is we are starting the program at 000h 0000h with the instruction org 0000h. Then we are initiating the loop counter, that is move r2 comma hash 0ah. Then we will initialize the ram address, move r0 comma hash 20h. After that we are using move dptr comma hash table, which will point to the table, okay, which is at the location 2000h, that is org 2000h, and this will point to this table. After that the main loop will start, okay, with the label up. Then here first the accumulator is cleared with this instruction move a comma hash 00h. Then we'll be fetching the data from the table by using the instruction move c a comma at a plus dptr. After that we'll write to the internal ram location. The data will be returned to the internal ram location by using move at r0 comma a. Then we'll increment dptr by using the instruction inc dptr. Once that is done, we have to increment the RAM location, that is the RAM address, increment R0. Then we will check for the loop counter whether it has reached 0 or no. If it has reached 0, then the program will be stopped. Otherwise this loop will be continued. Okay, so here it will continue until and unless R2 becomes 0. Here we have initialized the loop counter with 0 AH, therefore this loop will execute 10 times. Here this is just a sequence flow or the sequence diagram. What are the register we are using here? R2, R0, then we are using a data pointer and accumulator, and our RAM address is starting at 20H, and the lookup table that is starting at 2000H. And here we are using what? For program counter we are using move R2 comma 0AH. Okay, then here we'll be using the next instruction is what? Next is move R0. Okay, so this is the R0 register. Move R0 comma hash 20H. Then we have move dptr. So next instruction is at dptr. So it is move dptr comma hash table. Okay, after that we have a loop. Here this line, this gray line is nothing but the loop. In loop what we are doing is we are first instruction is move a, that is accumulator, move a comma 00H. Then next after that is we'll be fetching the byte from the table. For that we are using move a, that is it will be returned to what? Accumulator. Here this is written to the register. Okay, this value, program counter value, is written to the register. Then here it is written to register R0. Okay, after that the value is been written to the data pointer. Then move a, again here it is copied to the accumulator. Then we are again copying the value to the accumulator, that is we are fetching the byte from the table and we are writing to the accumulator. After that what happens? Here from the accumulator we will write the byte. Okay, from the accumulator to where? To this address, that is starting at 20H. Then after that we'll incrementing what? We'll be incrementing R0. Then we will be checking for the loop by using djnz R2 comma up, that is we are decrementing the counter, program counter. So this program counter is been decremented. If it is not 0, then this loop will continue. Otherwise this program will enter a infinite loop and it will halt. Okay, this is the sequence of the program. Now we'll execute the program. We'll open the Keel software. Maximize it. Go to project, new Vision project. Select the name of the project. I'll use the previously used project. I'll click on yes. Then search for the device, microchip. Click on plus symbol and search for 8089C51. Click on OK and click on no. Now go to file. Click on new file. Type your program here. I'll directly paste my program. Then save it. Okay. So I'll write the name as code to internal. Save this with the .asm extension. Okay, we have saved it now. Now here the target is created. Click on the plus symbol. Now right click on the source group 1. Click on add existing files to group source group 1. Now search for your program here. We have given the name code to internal.asm. Select that, add and close. Now again go to the source group 1. Click on this plus symbol and see whether your program has been added in this or no. So it has been added. Now go to project. Click on build target. So there are 0 errors and 0 warnings. So go to debug, start or stop debug session. Click on OK. Okay, now already our data is there at this memory address starting from 2000H. This has to be transferred to 20H. So in memory window 1, that is memory 1 window, I will give the location I colon 20H. So at I colon 20H, all the data values are 0. These values which are at starting from 2000H has to be transferred or copied to here, that is starting from 20H to 29H. Now we will go to again debug and run the program. So you can see here the values are being reflecting here. Okay, earlier it was 00, now it is 0102. These values which are there at from starting address 2000H, these has been copied to the internal memory locations. So this is how you execute the program. Hope you have understood. Thank you.